Okay, welcome to the new normal of Physics 220 lectures for the remainder of the semester. My plan is to not make each lecture very long, but maybe make several of them to encompass what would normally have been one lecture, and also not to go too slowly. Those of you who would like to spend more time can look at them again. Those of you who like things faster can just get a quick glance of it once, and that might be enough. So maybe this will help more of you. So I'm going to go through this parts of this PowerPoint right now, and it might be a couple of videos, and feel free to send me comments to let me know what works for you and what doesn't, and we'll proceed accordingly. So in this PowerPoint slide here, this is the warm-up problem. If you'd like to take a moment to do it now, feel free. Otherwise, I'll do it on the board. So you can pause now, do it yourself, or else just watch me do it, and then hopefully that'll help you. This is a reminder of the 3-block problem. In this case, it's just a 2-block problem, so it's even easier. So I have an 8-kilogram block and a 4-kilogram block. And we're ignoring friction, so I'm also pushing with a 20 Newton force on this side. So let me sketch all the forces acting on all the objects. I have force of gravity acting on that block. I have the normal force acting on that block. Force of gravity acting on this block. I'll call this one block 1, this one block 2. And the normal force acting on this block. Okay, force of gravity, Fg1 is equal to m1 times g. And because these are the only two forces acting in the vertical direction, they have to be equal to each other because there's no acceleration in the vertical direction. So I have that this equals, I'll take g to be 10 meters per second squared times 8. We've got 80 newtons. So that means that Fn1, therefore, is equal to 80 newtons. For Fg2, we have that that's equal to m2 times g, which is 40 newtons, which also has to be equal to Fn2, which is also 40 newtons. So we got those two forces taken care of. The other thing we're interested in is what is the acceleration of these two blocks. I'm sorry, this shouldn't have been 4 kilograms, this should have been 2 kilograms. I'll help my numbers come out clean. So I have an 8-kilogram block and a 2-kilogram block, both being pushed by a 20 Newton force. Well, this one's being pushed by a 20 Newton force. This one's being pushed by the 8-kilogram block. So I could rewrite this situation as one which will have the 20 Newton force pushing on a 10-kilogram block, which is the sum of those two. And if that's the case, I know that the net force acting on this 10-kilogram block is the 20 newtons. Therefore, the acceleration of this 10-kilogram block is going to be 2 meters per second squared, which is going to have to be the acceleration of both of those as well, 2 meters per second squared. Okay, so I'm going to erase a lot of this now. I hope you can get it down if you want it, and then I'll rewrite what else I need to put on there. I'm going to pause for a moment. Okay, continuing with this video, what I have now then is that I know each of these blocks has to accelerate at the same acceleration as this block, so they're both going to be accelerating at 2 meters per second squared. So the net force acting on this block is going to be its mass times its acceleration. So we have 8 kilograms times 2 meters per second squared. That's equal to 16 newtons. And I know the net force on any block has got to be equal to the block's mass times its acceleration. So, and the net, which is this, but it's also equal to the sum total of all the forces acting on the block. The 8-kilogram block has the 20 Newton force acting on it from this direction, and it is the force acting on it from the 2-kilogram block in the other direction. So I can also say that, I can draw the 8-kilogram block here. It's got a 20 Newton force acting on it from that direction, and it's got what I'll call F21 acting on it backwards. Okay? Just like what we saw last week with a 3-block problem, this is just with 2 blocks. All right? So I could say then therefore that the net force, which is 16 newtons, is equal to 20 newtons minus F21. F21 is the interaction force between these two blocks. So F21, therefore, those three dots means therefore, F21 has to be equal to 4 newtons. Okay? So that's the force that the 2 kilogram block is pushing back on the 8 kilogram block. Therefore, the force that the 8 kilogram block is pushing on the 2 kilogram block is also 4 newtons. So I could say confidently, because those are Newton's third law pairs, that F12 is also equal to 4 newtons. So I've just figured out all the forces acting on this pair of blocks. And this also, I can just check this. The 2 kilogram block here, by the way, this is a 2 kilogram block. It's being pushed on with a 4 Newton force. So it should be accelerating at 2 meters per second squared. There are no other forces. I mean, there's gravity and normal force, but they cancel. So the net force acting on this block, 4 newtons, is also equal to F12. And this would result in a 2 meter per second squared acceleration, which is what we know it's got to be. So that is the correct force acting on that block. So hopefully this review helps you remember the 3-block problem. And the next slide actually takes us through that. It also asks us what is the net force acting on each block. So you can think about that. We calculated it for both blocks also. And then the following question asks you which of these force pairs are third law pairs. And the only one that is truly a third law pair in this case is F12 and F21. The other two forces listed there are not third law pairs because they are acting on the same object. Third law pairs act on different objects, and they're also the same type of force in order to be third law pairs. Okay, and this takes us through everything we did. So all of the slides are kind of, for the first, on the review, they're up through slide 5 on the PowerPoint slide for today's class, are a reiteration of what I just did on the board. So here's a couple of announcements, and then I'm going to call an end to this video, and I'll start a new video for the next portion of the lecture. But exam 2 has been delayed a week. Clearly, we were going to have it last week, but classes got canceled. So I'm going to have exam 2 open after class, not Thursday, sorry, after class Wednesday. And projects now are going to be a bonus because of all the changes going on. If you choose to do a project, you can. Maybe I'll do some little practice projects on my own, little things I've been wanting to do for a long time. Now that I have all this time, haha, so to speak. I don't really have extra time, but maybe I'll be able to do a few more things. And there still will be quizzes. I'll have them on iLearn. There'll be iLearn quizzes, and I'll give you a time frame in which you can take them. They'll be relatively short, kind of like the ones you do in lab. And I think I'll be limited to multiple choice. Most likely that'll be the best way to do it rather than having you enter an answer. So it'll be kind of like the exams, but very few questions, maybe 3 or 4 questions at most. And the next homework 3, was the one that was going to be due a couple weeks ago. I delayed it till last week, delayed it again till this week. Once we cover friction, you'll be able to do those problems. Okay, friction will be in the next few slides that I will talk about in the next video. Take care.